So a few days ago, I picked up this blank MITS CPU80 S100 CPU card. It's for the 8080 processor. This is a reproduction card. You can pick this up on eBay or directly at www.theplanet.com. I can get that where you can see it. Theplanet.org. Let me take it back. Theplanet.org. Exchanged a couple emails with, I believe his name's Gary G. Kaufman at theplanet.org. See, it's a replica of the board. Apparently it was created by scanning an original unassembled board, converting it to Gerbers, etc. Really nice looking little board, so I'm kind of excited about this Altair 8800 project. I've got a reproduction front panel coming. I've already got a reproduction case for the Altair 8800. So this should be a fun build, and it'll be interesting to see really how I bring this together. So I've kind of debated with this board. I could use modern despiking capacitors on it. I could get away with quarter-watt resistors every place but down here, I believe. Don't have any half-watt resistors, or at least enough in my stock. I went ahead last night and ordered half-watt resistors for all the positions, and 2 watts down here, just so it'll look a little more from the period. Been looking for 0.1 microfarad disc caps that look more like what was used back in the period. In my stock, I found these 2 piles. These are a little big. They're 0.1 microfarad 50 volt. The lead spacing, however, will work well on these. In this case, this is what I've got in my stock, and if I had managed to get a blank board back in the day, I'd have been using as many parts as I could have. I think these will work well. They're a little tall, but that is what it is. If I counted correctly, I need 21, and of course I have 20 of these and a handful of these. So I will probably do these smaller ones out here kind of separate, and then stuff all these with the larger ones, which will look nice and symmetrical and balanced. In the original kit, I think the only socketed part was the processor. I'm going to, of course, socket all the IC sockets. The prices for the boards are reasonable if you directly buy off his website. I ordered a bunch of stuff on eBay, and he refunded the excess shipping, which was much appreciated. I'm really looking forward to it. The board itself is close enough to the original design, if not exactly like it, although it's silk screened and solder masked, etc., that you can use the original assembly manual that came with the original boards, which is what I have a printout here of. So I will be following this somewhat in the order here that the manual calls out. I'm going to most likely change a couple things, as I always do. One thing to note, I've mentioned this before, is I have taken 600 DPI scans on my flatbed scanner of both sides of this board and confirmed I have good scans. One thing that does is capture all the silk screens in real high resolution. Like the resistor numbers here are kind of cut off by the solder pads. But that has come in handy a couple times when a board doesn't work and I'm trying to figure out why a signal isn't getting where it's going. And I'm able to look at that high-res scan, and a couple times I've discovered things like where a trace was over-etched up against a pad and wasn't making contact, and that shows up well in those high-res scans. It's a lot harder to spot on an assembled board with like a magnifying glass. So it's just something I always start with. It just makes a lot of sense to do. It helps me document the build as well. I tend to document fairly well what I've built. I'll do an as-built documentation if I make any part substitutions. These electrolytic caps are 33 microfarad. I've actually ordered some caps with the radio leads as well. What I have in my stock are 100 microfarad, and physically they're the right size. And I really suspect those are just power supply filter caps. I mean, looking at these guys here, they definitely are power supply filter caps, it looks like. 100 microfarads would most likely be fine. I don't have the 2 megahertz crystal to go in here in the large style cases at T58. I don't remember what that case is. I have 1 megahertz and 2.4 and various others, but no 2 megahertz. I will look on eBay to see if I can get one of those. It'll use a newer 7805 just because they're more reliable and they don't oscillate as much. Or they don't tend to go into oscillation nearly as much as the really old ones, although I have 7805s that would be very close to the date code this board was originally designed and sold. So kind of with that there, I am going to socket everything. I think I've already said that. There's a couple things in the assembly order you need to worry about. There are some jumpers that get put in place. If I can find something to point with here. So there's a really long jumper wire here, and another one here, and this really long one routes underneath these caps that'll stand up here. So it'll be underneath the various despiking caps that'll go through this way. So that wire needs to go in before the caps go in. It'll just be easier to do. Took me a while to find this jumper up here, J2, next to the processor. There's a short jumper down here. Yeah, J4 to J4, and then there's J5 to up here underneath this cap. So that's where the assembly order starts to become important. This R, I believe it's 17, solders up kind of underneath the electrolytic that'd go here, so it would want to go in first. So that's some of the details the manual gets into without actually calling that out in reading it. The manual has you stuff all the resistors first, which is always a good step. I'm going to actually stuff the sockets first. I tend to like to work from the lowest profile components up to the highest. That way I can flip the board over and have a bit of pressure on the components. But in this case, I'm going to start with the sockets. They may actually end up being the majority of the lowest profile components because these are going to be 1/2 watt resistors and 2 watts here. They'll be rather large. You could see those disc caps are rather large. So I think with all that said, I'm going to fire up the soldering pencil and start looking at putting sockets on the board. I'm just going to move all these caps out of the way here. They'll get put in a later video. But we'll start with soldering up sockets here. I tend to go, I've debated this over the years, I tend for me to go from the largest sockets to the smallest sockets. It's really easy to accidentally, and I've done this, put a 14-pin socket in where an 18-pin or a 16-pin goes and get it soldered up and then realize, oh crud, I've got the wrong socket. Whereas you can't put a 16-pin socket, I know I've got a bunch of them laying here, in a spot for a 14-pin. It doesn't physically fit. And going largest to smallest, I tend to keep myself from doing that. I think some people have talked about going from smallest to largest. I think most people don't honestly care. You just put them in. That might be a single wipe socket. Looking at it, matter of fact, that is. I am not going to use that 24-pin. It's a single wipe. So it's a really cheap socket. Single wipe means it only makes contact on one side of the IC pin, where these double wipes have a loop of metal that contacts the pins on both sides. Single wipe sockets are notoriously unreliable. Double wipe give you tension on both sides of the pin and help create an airtight as possible connection between the pin and the metal in the socket. You want that connection as airtight as possible because that reduces oxidization over the long term. So kind of with that, all that said, I am going to do a couple of other things here. I am going to place a 16-pin socket in a spot for it, and a 14-pin over here, and I'm going to tape those in, and that'll help kind of keep the board flush when I have it flipped over to solder that 40-pin. Well, it would help if I didn't pull the socket out with the tape. Makes the board a little more stable because it's got 3 points here towards the bench. I keep doing that. I'm determined to pull that socket up out of there. But rather than have the board kind of flexing back and forth on that socket, I can set it down here and get a good stable base for soldering. It's just one of those things that makes soldering a little bit easier. Oh, it's the constant. Where are the glasses? I actually broke my really good close-up glasses. These will work. I am using a little bit larger tip here than I typically do, although it should be fine for this. I've cleaned it and tipped it. I'm at 350 degrees C, my preferred working temperature. That did not solder well. See, this is a little bit confusing. There's 2 extra pads here that don't have socket pins through them, and that's for that jumper link. No, the jumper link's on this side, so I put the socket in the wrong location already. So let's go ahead and remove the socket. That really sucks I did that, but this is why you check and double check. There's an extra set of round pins up here for a jumper link, and I managed to get the socket offset. Let's see if I can just reflow that and push the socket up into place. That's better. I will tack down this corner, and then I will push gently just to make sure it is seated. And I'll just walk through and solder all these. I had a viewer comment, I've never had this one before, saying, why are you shooting in 60 frames per second? It makes the playback all jittery and ugly. Gave me a thumbs down and said I'm not going to subscribe. It's the first kind of complaint I've had. I've shot 30 frames per second in various lower resolutions over the years. I shot for a short period of time in 4K and really was unhappy with the results. It was a pain to edit. The files were very large. YouTube, of course, down converts as it wants to. And I went back to, well, not 4K, 2K, whatever it's called, 1920 by, don't even remember now. And I've been shooting in that for quite some time at 60 frames per second. Though that's probably a waste for YouTube. I've looked at all kinds of recommendations on, you know, the right video quality to shoot. There's as many opinions out there as there are websites. If people are unhappy with the quality of the videos, you know, let me know in the comments if I should be shooting 30 frames a second and you believe that would produce better content. Let me know. You know, I'm producing this content for you. As I've said before, I'd be assembling this even without the videos. I've been doing this kind of build my entire life, really my entire life. Now I am going to go ahead and tack in these 2 ones out here on the edges, even though it kind of breaks my, what I said, go from largest to smallest, simply because it lets the board be stable. You know, while I'm working here, it's not flopping around. And I know, at least for these 2, I have the sockets in the right place. Now, is that a lead hole there? Yes, it is. There's supposed to be a jumper. So solder flowed over and filled that hole, and then there's supposed to be a jumper link there. And if you were soldering directly in ICs, that really wouldn't be an issue. So I'll have to clean that hole out and get a jumper link in there. If I'd have done the jumper links first, actually, I wouldn't have got that socket in correctly the first time around. So maybe the jumper link should have gone in first. But it's nothing I can't fix. Don't know that I have proper wire here. I'd like it to be white wire like was originally supplied, just to make it look a little more authentic. But I'll have to look. I don't know if it originally came with solid core or multi-core. Again, it'll kind of be depending on what I can find here. I don't tend to stock new wire just because there's so much salvageable wire out there, but it does kind of limit my options. Those are in, the notches are the right orientation. They're flush to the board. I'm really happy with that. So I won't bother or bore you by soldering the rest of the sockets in real time here. I'll just do another high-speed kind of shot of me putting them all in that'll get edited in. So I will see you in a second in the next step of this. So I dug around and found some multi-strand wire that seems like it'll work. It's small enough diameter it'll fit through the holes in the PCB. I've cut these to what I think will be a good length. I am going to tin them. I pre-tested tinning one, and it fit through the hole of the PCB just fine. So just makes them a little easier to get in when they're tinned. You don't have a stray, bit of the copper from the multi-strand, poking out and not being seen and shorting something, or same time I got to keep this tinning pretty light, because if I get too much more diameter on the wire, it will not fit through the hole. I suspect they probably used a solid core wire. I don't know that. I don't really have a bomb for this. Really just have, the notes in the manual. But I think I really should have put these in first. Again, of course, I'm breaking with, I think, the order of stuff in the manual. I'm using a little bit of cardboard here in the helping hand so that I don't deform the insulation on the wire. This insulation is pretty soft and melts pretty easily as well. But I think for what I'm after here, if I just use the alligator clip on the wire itself, and the other reason I'm keeping the heat as far away from here as well so I don't deform the plastic, the insulation on the wires melts really easily. And deforms really easily, so yep. It's interesting that they ended up with these links. I'm assuming they just couldn't get the PC board to route without them. This was definitely, I would say, a hand routed board. I mean, this was very early in the days of microprocessors, and you do routing with computers, and computers were huge and expensive and all that kind of stuff. So we've tinned up 5 links. Let's see if we have any luck. So we've got J1, which has a little too much solder on it. Let's see if trimming that big bulge off the end will get it through the hole on the board, or if I need to take a little bit of the solder off. So I did test this, and I had luck with the test one, but those are always famous last words. There we go. So he's going to go from there, J1 to J1 is over here. It looks like that fits pretty well. Gives it a little bit of slack. Don't want the dwell time here to be too long, or it will melt back the insulation. Where's the other end of that? It's way over here. And I'm going to apply a bit of pressure and just reflow that quickly. That one definitely moved. Ah! Soldering pencil fell out of the stand. So that's not too horrid. It fits along the dotted line pretty well, so my length is pretty good. Trim back those leads. We have a very short one. Actually, I need to clear out one of the holes that accidentally got filled up here, and I've prepped the soldering tool in advance for that. Right here. That unsoldered the IC lead as well, but that's okay. This one's really short, and it might actually have been better to not even use a piece of insulated wire. So I'm going to bend that kind of in a U shape. Find a pair of needle nose here and see if I can get it to go down in there. There to there. That's really tight up against that socket. It would have been smarter to put these in first, but where would the fun be in following the instructions? Are you going to go through there? There we go. So that's J4 to J4. Actually went in pretty well, so my sizing on it was pretty good. And it's from here to here. And I'm going to reflow both of the pins there, although I don't like the looks of that solder joint now. Should have done this first, but we're recovering just fine from it. And we have this one, which is J5. Not sure what that hole there's for. It doesn't seem to be for a jumper link. That's 4 to 4. 5 is there. Come on, you can go through there. That one is too short. think because I measured it against the wrong holes. I did have a little extra piece here. Is it long enough to replace this? I think it is. This was meant to replace this. I don't think it's that much longer. Well, it is. Guess we'll find out here. Where's the little cardboard protector I cut? Tin this and see if it's any better. I can hear my 3D printer downstairs making noises. I'm printing out card guides for the Altair motherboard or backplane. He's meant to go from there up to there, and that's lengthwise looks like it's good. There. Well, I'm happy with that. Do I have a piece of loose tape floating around here? Okay, first recommendation, put the jumpers in first. Although, you know, technically this board wasn't meant to be socketed. It was, you know, the TTL ICs were just soldered directly in. I've chosen to socket it, which is different from really the original intent, just because I think that's a better thing to do. Definitely my preference to spend the money. I debated whether to do machine pin sockets for this board. They're 3 to 4 times the cost of a non-machine pin, and just decided, you know, for what it is, I'm not going to do that. We have 3 of them in. We have one that routes from here down to here. Again, that length feels pretty good. It follows the dots on the PCB pretty well. Gotta get it taped down to hold it in place. And I can't spot where it's at. It's over here to here. I am going to reheat and just press down slightly. I felt that one move a little bit. I'm sure this one here will as well, and it did as well. Ow, the wire got very hot. I keep having the pencil fall out of the stand. Not sure why. That's in there. It's enough it can be moved around for other soldering. And finally the jumper link up here by the processor. And we'll see how close I got the spacing on those. Again, that looks really good generally. Flare the wire on the other side just a bit to help hold it in place. And I'm generally happy with that. So J2 is jumpered to J2. J1 is jumpered to the wrong place. Maybe. No, wow, that is not obvious. So the dotted lines come across and then bend down here. All that is labeled J1 there, so that's good. J3 to J3. J5 to J5, J4 to J4. So I think I've got the jumpers in. And then as we kind of discussed a little while ago, these spiking caps, these 0.1s, will you know, sit over. I'm gonna have to do some lead bending over this jumper wire here. Yeah, those leads aren't fitting really well. See if I can get something that well, it's going to need more finagling than that to actually get it size-wise where I want it to be. Actually, that's not too bad. We'll go somewhat like that. Whether I'll use these really large ones is still debatable. They're a little big. But you know, the lead spacing between those is really big. I could go with much more modern, tiny. I won't give it that old school look I'm kind of looking for. So, you know, there's the tiny bit of rework and getting the jumper leads in place. And of course, the one we couldn't use because it was a little too short. So my eyeballing of that one wasn't perfect. But generally happy with that. That's not bad. So I guess now back to the sockets. I didn't count out the number of sockets correctly. I had to go fetch another 16 pin out of the container. But that's okay, we'll do this last one here together. Actually kind of makes me wonder if I dropped it on the floor or something. I just lost it. So I did count out the sockets by actually dropping them into the board as I sorted through them. So a bit of a mystery. I just somehow missed a socket. Oh, that tip is grubby. broken solder joint there. That one's kind of dull. Well, generally I'm happy with the soldering there. So there we have it. We've got all the sockets in.